let's take a look at number 2. Again, this first line is just giving us points on the original function. So when x is 0 on the original function, we get 3 out for y. Put -2 into the original function, put 2 into the original function, we get the same y value, -4. So it doesn't matter whether x is -2 or +2, we get -4 out for y. So those are our 3 points we're starting off with. So we can go ahead and plot those, 0, 3, -2, -4, and 2, -4. Second line tells us when the derivative is 0. So these are all our critical values. And we have a critical value at -2, 0, and 2. So those points that we actually graphed are all of our critical values. So we're going to put those on a number line for our derivative. -2, 0, and 2. It's nice, we don't have to plug numbers into a function to figure out when it's increasing or decreasing. We can just use the information given to us. It tells us the derivative of f of x is greater than 0, so it's going to be positive between -2 and 0, and when x is greater than 2. So our graph's going to be increasing in those two intervals. Increasing from -2 to 0, and from 2 to infinity. Derivative is negative in our other two locations, when x is less than -2 and when x is between 0 and 2. So decreasing from -infinity to -2 and from 0 to 2. These are all derivatives of 0, so we have nice smooth curves at these points, unlike number 1 where we had a sharp turn. So if we graph this, we know we're going to be decreasing first, right? We're going to be going down, then we're going to be going up, which is going to make -2 a minimum. Then it's going to be increasing, and then at 0 changes to decreasing. So going up and then going down, we're going to have a local maximum there. And then finally down to up, that's going to give us another minimum. Going coming down to this point, switching directions, up, down, and then up. All smooth curves, no sharp turns, sharp corners. And that's our graph for number 2.